Okay, so we are back with homework 7, and we're figuring out what is the greatest common factor, and then using the greatest common factor to um, kind of change an expression to look a little bit different. So when we talk about greatest common factor, I'm going to do something simple before we get into what we've got today. And so what we're going to do is we're going to find the greatest common factor, or GCF, of 12 and 18. And so what I like to do this is I like to say, okay, here's 12. To get 12 by multiplying, I can do 1 times 12. Oops. 2 times 6, or 3 times 4. And this is called a factor tree, I think is the fancy name for it. But basically, I just list and I start counting 1, 2, 3. And then once I get to a number that I've already got, I know I'm done. So I went 1, 2, 3. And we can see that I could go to 4, but I've already got 4. So it would be 4 times 3. I would just be repeating myself. So I'm going to stop there. And then with 18, similarly, 1 times 18, 2 times 9, 3 times 6, 4 does not work, 5 does not work, 6 does work, but I've already got it. So I know that I can stop. And I have completed my list of all of the common factors between 12 and 18. And so the greatest common factor is basically the biggest number that can multiply by something else to create this number. And so in the case of 12 and 18, I can see that the biggest number that are in both spots here is the number 3. So the greatest common factor of 12 and 18, no, I'm wrong. I just caught myself. So I do need to keep going. So 3, no, I don't need to keep going, but I saw 3, but I see something else. I see 6. So the greatest common factor of 12 and 18 is 6. And so it's important, as I just demonstrated, to look at your list carefully. So in the case of this one, we would be able to say that our greatest common factor, or GCF, of 12 and 18 is 6. Okay, so we'll talk about how this affects variables as we go through the homework assignment and stuff like that, but basically that's what we're going to do to find the greatest common factor of a couple numbers. And so we'll do this with number 1. We'll make a factor tree for 9, and we'll make a factor tree for 8. So to get 9, I can do 1 times 9. 2 does not work. 3 times 3. And I've got 3 already, so that would be just repeating. I'm not going to go any higher. 8, we've got 1 times 8. 2 times 4. 3 does not work. 4 works, but we've already got it. And this is kind of an odd pair because the only number that they have in common is 1. So the greatest common factor here is going to be 1 in terms of the number. But we also have to consider the variable. So we have a w to the power of 3, and we have a w to the power of 2. Now, in taking the greatest common factor of something like this, all that we need to do is recognize that we can only take out the lowest number of w's that we have. So the lowest degree would be the fancy math way of saying that. So we need to find the variable with the lowest degree, and that's all that we can take out. Because, for instance, I could take 3 w's out of here, but I can only take 2 w's out of there. So we're limited by the one that is the lowest. And so the w's that we could take out from this would be w to the power of 2, because that is the lowest degree or lowest order for this. So for our greatest common factor for this, we'll have a number. Part of it is a number, which is 1, and part of it will be a variable, which is w to the power of 2. So both of those terms in the directions there could be divided by 1w to the power of 2. And that is the largest term that they could be divided by, and come up with a whole number as a solution. Similar with 8y and 11y. I'm not sure why they chose 8 and 11, because it's going to be the same thing, that the greatest common factor is 1. That's kind of weird. We do a factor tree. 1 times 8. 2 times 4. 3 does not work. 4 does, but I've already got it, so I can stop. And the only factors of 11 are 1 and 11. So again, 1 is the only thing that they share. And then again, we have to go with the variable that has the lowest degree. So for instance, again, on this one, I could take out three y's, but on the other one, I'm limited to only one y. And so again, we have to go with what is the lowest. And so we can only take out one y. And so our greatest common factor for this is going to be 1y. That's the only thing that I could divide both of those terms I was given by and come up with a even result. I don't like it when my iPad does this. It makes like weird, glitchy. Okay, there we go. So now we have something a tiny bit more complicated, but not bad. And the way that I would suggest that you deal with this in the beginning here is to consider these as two separate numbers, two separate terms. And so I have a 15w to the power of 2, and I have a negative 10. And it's, oops, my iPad just disappeared from the screen. Let's see if I can fix that. I'm going to pause this while I try and remedy that situation. Maybe I don't need to, it'll come back quickly. There we go. Okay, so remember that the number in the sign in front of the number stays attached to the number, so that it is a negative 10. It's not really going to matter for coming up with our factors, but for coming up with factors, I'm not going to worry about the sign. Actually, we're just going to consider the number. So factors of 15w to the power of 2. First off, we're only going to look at the numbers. I'm going to ignore the w to the power of 2. And so 15 will have factors of 1 times 15. 2 does not work. 3 times 5. 4 does not work. 5 does, but I've already got it. Negative 10. And again, we're just going to consider that as a 10. We'll have factors of 1 and 10. 2 times 5. 3 does not work. 4 does not work. And we already have 5. Okay, so from the number side of this here, we can see that our greatest common factor is 5. And then from the variable section, we can see that we have a w squared, and we have no w's on the other one, on the 10. So the 15 has a w squared, but the 10 does not have any w's at all. So that means that we can take out no w's, because both terms, the 15w squared and the negative 10, don't have at least one w. And so all we can do is divide by the 5 to factor this expression. And so what we would do is say, okay, we know we can take a 5 out, or divide a 5 out. And when we divide 15 by 5, we're left with 3, and then it's still a w squared. It's important to remember that that 10 is negative, and we took out a positive 5, so negative 10 divided by positive 5 is negative 2. And so this is what the factored expression would look like. And a way to check that, it's nice that we have the ability to check these. We can do the distributive property, and for the distributive property, I like to use this thing. I call it a box method, as opposed to the arrows. And so we would multiply 5 by 3w squared and the negative 2. And we can check and see if we get the same thing that we started with. So 5 times 3 is 15, w squared, and 5 times negative 2 is negative 10. And so we do get 15w minus 10 if we go ahead and multiply it out, which is equivalent to what we started with. So this 5 times the quantity 3w squared minus 2 is what the factored form of this expression would look like. Okay, on to the next. So this time we've got 9 and 15 as the numbers. So 9 and 15 are what we need factors from. So we've got 1 times 9 and 3 times 3. And for 15, 1 times 15. 2 does not work. 3 times 5 works. 4 does not work. 5 works, but we've already got 5, so we can stop. And we see that our greatest common factor is 3. Now in terms of the variable portion of this, we have a y to the power of 2 and a y to the power of 3. Again, we can only take out the lowest number that we have, which in this case is a y to the power of 2. So the piece that we're going to factor out is going to be a 3y to the power of 2. And so again, this is division. So we just need to basically consider this as division. So 9 divided by 3 is 3. Y squared divided by y squared leaves no y's. They would cancel each other out if we divided that. And then we still have a negative 15 over there. We got to be careful about that minus sign. 15 divided by 3 is 5. And y to the power of 3 divided by y to the power of 2. If I was to write that out, leaves just 1y, or y to the power of 1. And so that is going to leave a minus 5y over there. And again, we can check, as we did in the last problem. 3y to the power of 2. I don't know why it keeps doing that. That's so annoying. Okay, you got it back. And so we can check by doing the distributive property, and as with the last problem, I like to use the box method, 3 and a negative 5y. So 3y to the power of 2 times 3 makes 9y to the power of 2. 3 times negative 5 makes negative 15. Y to the power of 2 times y makes y to the power of 3. And so, yes, we ended up with the exact same thing that we started with. So this is what we would call the factored form of that expression. Okay, last one. Similarly, we're going to do the same as we have been doing. We are going to factor 8 and 6. So we get 1 times 8, 2 times 4. 3 does not work. 4 works, but we've already got it. For 6, we've got 1 times 2. No, 1 times 2. 1 times... Apple Pencil is doing funky things today. We got 1 times 6, or 2 times 3. And so we can see that our greatest common factor here is going to be 2. And then in terms of the variables, we have a c squared and a c to the power of 3. Again, we can only divide by the lowest number that we have. So in this case, it's going to be a c to the power of 2. And so what we're going to factor out of this is a 2c to the power of 2. And again, factoring is just dividing. So 8c to the power of 2 divided by 2, c to the power of 2 is going to be 4. And the c's would cancel each other out. C to the power of 2 divided by c to the power of 2 is 1. So we don't need to put anything there. Again, we have a minus sign here. And 6 divided by 2 is 3. C to the power of 3 over c to the power of 2 is just 1c left, because 3 minus 2 is 1. So, and again, we can check by doing the distributive property. And so 2 times 4 is 8c to the power of 2. And here we would have negative 6c to the power of 3. So it matches what we started with. So this right here is the factored form of that expression. That's it for homework number 7, I think. Yep. So I hope this is helpful, and I hope you have an awesome day.